A KQED HD production.
Every winter, thousands of very loud, large visitors storm the beaches of Año Nuevo State Reserve, a jagged stretch of coastline 60 miles south of San Francisco. They attract quite a following among the curious and the intrepid, who trek for miles up sandy dunes and past coastal brush to glimpse these denizens of the deep.
Over there, you see an alpha bull fighting another guy who wants to be an alpha bull. You don't even want to think about how that guy in the water feels.
50,000 tourists a year come to see the marine mammals during their breeding season, from December through March.
I like elephant seals because they don't look like any other animals. They are huge.
Elephant seals are the largest seals in the world. Male northern elephant seals can be up to 16 feet long and weigh up to 4,500 pounds. Brawn trumps brains as the males fight for the much smaller females who congregate in harems dotting Año Nuevo, which was named for the New Year's Day in 1603 when it was first spotted by Spanish explorer Sebastian Vizcaino. Today, there are about 4,000 elephant seals at Año Nuevo State Reserve during the breeding season. It's a testament to their astounding comeback from near extinction roughly 100 years ago.
The animals were exploited for their blubber, which was reduced to a very fine oil.
By the 1890s, only about 30 elephant seals survived, confined to Isla de Guadalupe, a volcanic island off the coast of Baja California. In 1922, scientists from the California Academy of Sciences made a survey of rare animals on the island. They found a small herd of elephant seals. A few months later, the Mexican government declared the island a protected reserve.
All of the 170,000 elephant seals that exist today trace their lineage to the 30 individuals that survived on Isla de Guadalupe.
Today, the population of northern elephant seals is robust, with breeding colonies scattered from Point Reyes National Seashore to Baja California. And for male elephant seals, mating is a high-stakes game with few winners and lots of losers.
One male may monopolize mating in an ideal situation with up to 100 females.
With their noses inflating with air, the males trumpet their battle call. And it's not just the tourists who return year after year, captivated by these strange, striking leviathans living life on the edge.
They just really are amazing animals. I mean, everything they do, it's to the extreme. They're extreme divers, they're extreme fasting animals, they're extreme in their ability to conserve water.
Marveling at their massive girth splayed across the sand, athletic may not be a word that readily comes to mind, but they can dive and swim past much of their animal competition.
Elephant seals are really animal Olympians. When it comes to diving, the only other group of marine mammals that even come close to them is the sperm whale and beaked whales. They're diving to routinely between 1,500 and 2,000 feet of water, and occasionally they'll dive for almost 2 hours. They have an incredible ability to store oxygen. 20% of their body weight is blood, whereas in you or I, it's about 6 to 8%. Of that blood, more of it is red blood cells, so that 65% of that animal's blood is red blood cells, where in humans, it's about 40 to 45%.
Elephant seals also travel twice a year, up to 12,000 miles, to forage for foods such as fish and squid. So studying them when they're underwater for most of their lives requires high-tech tools.
And if you go to this textbook from 1990 on pinnipeds, here's where we thought the distribution of northern elephant seals up from Vancouver Island up here down to the middle of Baja California, and then a few hundred miles off the coast. Once we put a satellite tag on the animals, we found that elephant seals were using virtually the whole northeastern Pacific Ocean. We had no idea this is what they're doing, because when they're spending 80 to 90% of their time underwater, when you drive by in a boat or you fly by in a plane, most of the animals are underwater and you just don't see them. The satellite tags are giving us a much deeper, richer understanding of where these animals go and where they lived and where they spend their time, and it completely has changed, literally, the textbooks.
Since the early 1980s, marine biologists Bernie LeBoeuf and Dan Costa have tinkered with technology to peel back the ocean's dark veil and reveal the secrets of the seals.
We were among the first to attach video cameras to elephant seals. The animal would return within 2 or 3 days, and we had a visual record on video of what the animal saw in front of it or behind it. What we found is that when the animals leave the shore, it has to cross the continental shelf, which is the shallow area that goes out 10 to 15 miles. Over that shallow area, the animal is traveling very quickly. The white shark is a major predator, and this is where it makes a living. So the best thing for the seal to do is to minimize its time at the surface when it's most vulnerable.
Today, this seal surveillance has met the digital age. Since 2000, Dan Costa and his students at the University of California, Santa Cruz have tagged more than 300 elephant seals.
I'm involved in a project called the Tagging of Pacific Predators, and it's a project which takes the approach that we've had with elephant seals but magnifies that to look at how the northeastern Pacific Ocean is used by different species of marine animals, not just marine mammals, but marine birds, sharks, fishes, and turtles.
The tagging is revealing how critical certain regions of the ocean are, not only for elephant seals, but also for the survival of their marine neighbors.
There's a group of animals, elephant seals, northern fur seals, salmon sharks, and albatrosses all feed in this region of the North Pacific Transition Zone. It's this region between the colder and warmer waters of the North Pacific. So this is colder water here, warmer water, Hawaiian Islands, and all these little squiggles or worms or northern elephant seals. And you can see that they really like this area on the sort of cold water side of this big system. And we call these fronts, just like we have a weather front coming in the atmosphere.
None of this groundbreaking research would have been possible without innovative tags, which keep getting smaller and smarter.
This tag just measures time and depth. This tag just gives us animal location, so it transmits to Argos satellites overhead. This tag tells us where the animal is, what it's doing, and gives us much higher quality locations. And you can see it's already, I have to hold these two things together. This does it all. If you look back here, you can see we can look at any given day, and within 2 hours of the receipt of this transmission of the animal's location, we can dial up via the internet and find out where the animal was when those data were transmitted.
What about the ones in Japan?
Fortunately, Dan Costa has a team of passionate graduate students to help him.
Yep, we've got a couple on the beach and a few more pretty close.
Today, the researchers prepare for the returning seals and the clues they carry about their lives at sea.
A lot of head movement. We're at Año Nuevo State Reserve in Northern California today, and we're here to recover satellite tags from an adult female northern elephant seal. So on a typical day where we're retrieving a satellite tag, we locate the female that we've been watching. And as we sneak by all the seals, we're getting ready to give an initial injection of a mild tranquilizer, basically to make the seal fall asleep, so we can safely retrieve the tags.
46, act.
And then we check the health of the animal. And looking at her, she's probably about 500 kilograms. So she's quite a large northern female elephant seal.
She's off.
Someone read it?
547.
547. We start taking measurements like blubber thickness, blood samples, and we also take whiskers.
This essential fieldwork is also a reminder of the cycle of life and loss which marks the breeding season.
She did not have a pup with her. She has given birth, and we have observed her for multiple days with a pup, but sometimes in the craziness of the harems with male fights and things, they lose their pup.
Back at the lab, Nikki analyzes a whisker to answer a surprisingly tricky question. What do elephant seals eat?
A stable isotope analysis allows us to have somewhat of a dietary fingerprint. So as the whisker grows, its composition changes with diet, and I can learn more about what they've been eating out at sea. This tool is allowing us to no longer be in the dark. We don't know exactly what these animals are eating, but we do know that they're top predators. They're foraging at the top of the food web, and that juvenile elephant seals are foraging on different things, which is something new. We did not know that animal A is going to be doing something different from animal B.
But an ocean of unanswered questions still remains.
If you have a female that goes out to the international date line and turn around and come back like a beeline and finds the Año Nuevo Reserve, how does she do that? How did they dive for 2 hours? What's the metabolism? How do they change their ability to store oxygen? How do these animals take the pressure? It always amazes me that after all these many years of studying these animals, that there's still so much more to learn. It's what drives me. It's what drives a lot of us that do this.